Welcome to the FCICA Product Webinar Series. We are pleased to have Shane Jenkins of Schonox HPS North America, Inc. with us today. Shane, the floor is yours.
Good afternoon, everyone. Thank you for joining us for our FCICA webinar. My name is Shane Jenkins. I'm the Senior Technical Coordinator here at Schönox, and we are pleased to present this presentation to you for our members and our guests. I just want to give a few housekeeping rules on this seminar. This is a registered CEU with Health, Safety, Wellness applications. It is registered with the Interior Design and Continuing Education Council. It does offer CEU credits, so if you will give me your information after this seminar, I'll be glad to present that certificate for you. This CEU is also accredited by the U.S. Green Building Council. It is a LEED certified CEU, so LEED credits are available for members of U.S. Green Building Council. Again, if you'll give me your information after this series, I can get certificates to you. And we are registered with the American Institute of Architects. This is a HSW certified CEU. We will go by AIA format, so we will not talk specific construction or product during the presentation, but we'll hold those questions until the end. So again, welcome to our course description today. We're going to be talking about self-leveling technology. We'll be talking a little bit about the history of self-leveling, where it comes from, where are some historical uses and some applications of these products, how do we see them in today's modern construction, and then maybe some of the new technology that's been emerging in our industry within the last 20 years. So again, understanding the history, understanding our modern applications, looking at the different components that make a self-leveler, and again, some new technology in the self-leveling compound industry. So welcome to the evolution of self-leveling. If you guys are quite familiar with the word self-leveling, in itself was quite a misnomer in our industry. We thought that we could just take a bucket of material, apply it into a application, and it would find its magical spot within the project. Guys had to really manipulate and work this material a little bit, so self-leveling has evolved tremendously in the last 20 years. Primarily what you guys will come across will be either a cementitious type self-leveler or a gypsum-based self-leveler. That's the distinguishing factor we use within our industry. So let's kind of look at the history of each one of these and how we're coming to the points today. When we're talking about self-levelers, the first binder system that we see is actual gypsum. Gypsum was created over 25,000 years ago, established in 2505 BC by the Egyptians. In 1888, we see calcium aluminate, and we also see our first gypsum self-leveler produced in 1935. So what is gypsum itself? Gypsum is a crystalline structure. We find this in abandoned seabeds and salt beds. We find it a lot in the Silicon Valley. We find it in Baja, Mexico. It's a large depository of gypsum today. It is a mine structure. You can kind of see in your slides at the bottom left-hand corner, this is actual crystalline structure of gypsum with a guy sitting in the middle of that crystalline field. We also have a gypsum flour that is produced even in the totally neutral soil. So historically, we see the gypsum being used again by the Egyptians over 5,000 years ago, used to build the pyramids. So the mortar system that was used in between the limestone block was a gypsum material. In the city of Jericho, we see that walls were constructed with a gypsum mortar, and actually vessels were made out of gypsum or alabaster and found in the Middle Age Bronze era. We also see it in European buildings and construction. Cobblestone was actually placed together with a gypsum type mortar and material. So modern applications we're seeing today: toothpaste, peanut fertilizers, sidewalks and chalk, dental molds and splints. For us in the construction industry, we see it in self-leveling and feather edge products, and primarily in the United States, we see it in the use of drywall. So looking at property and the benefits of natural gypsum, it's best suited for a critical background. That being said, that is something that would be like a vinyl asbestos tile, a critical substrate of existing gypsum, even a plywood substrate. Natural gypsum is very good for that one layer application. It can be done at thick applications in one lift. So it's very lightweight and has good fire retardant capabilities. The disadvantage of a natural gypsum, it is a mined product. So we do have a variation in quality. There's some impurities that can be found within natural gypsum itself. So using it as a subfloor, as an underlayment, it begins to crumble over time, leaves it very unstable, very low compressive strength, very low flexural strength, very inconsistency in the quality. And then some manufacturers actually add compounds within that self-leveling, which can lead to mold and mildew growth. So that's really where gypsum in itself has really got a bad reputation in the construction industry. So when we have moisture getting in contact with the natural components of natural gypsum, we do have mold and mildew growth. And that is a very strong concern of our construction industry and our architects and designers as well. The next binder system we see in existence is actually Portland. 1756, British engineer John Smeaton invented the first Roman concrete or hydraulic concrete. And in 1824, Joseph Ashburn invented Portland, named it after the rock quarry that was located next to his facility. Portland has become probably the most prevalent binder system that we have in the industry today. So what is it? Calcium, aluminum, iron, lime, and silica is the major components of Portland. Lime and silica probably being the most prevalent in that industry. It starts out with limestone, and then it's crushed and milled. And I'll show you a little bit about that process here in a moment. So where are we seeing Portland being used at today? So your modern construction, walls, floors, sidewalks, interior, exterior applications, you're probably looking at Portland type cement. Properties of that cement type material, it's very strong, very durable, very dense concrete. It is water resistant. So if we're looking for a self-leveler with water resistant capabilities, we're going to have something that's going to have a Portland-based binder system. Disadvantages of Portland, it is going to shrink and it does crack. Kind of the rule of thumb that all concrete will get hard and all concrete will have cracks. That is one of the disadvantages of Portland because of the shrinkage that's in it. The third binder system we see is actually calcium aluminate cement, made from limestone and silicon bauxite. Bauxite is an aluminum ore, patented in 1908 by the Labide and Lafarge Company. In France, if you ask for calcium aluminate, it's actually known as cement fondue, and I'll show you why it's listed as that here in just a moment. But in 1918, after industrial manufacturing testing trials, the French government had to have a way in order to get tunnel systems built within the French winters. They were trying to construct this to get transportation done during World War I. So this is where we're first seeing the modern applications of calcium aluminate. And then today you see it in bridge and road construction. When they need a very high PSI strength and lower temperatures, it's normally when we're seeing the use of calcium aluminate cement. So high early strength gain with this material. We have upwards of 6,000 PSI within 6 hours at 68 degrees. Higher heat hydration than you would with Portland cement. The disadvantages of it does lose its capability of working within 10 to 20 minutes. So for self-leveling, sometimes we need a little bit more working time. And it can also go through a process called conversion, which will actually make a gel instead of a crystalline structure, which gives you loss of strength in this material. We can decrease water, add a little extra limestone, which helps eliminate some of that conversion process. And some of the impurities in that will actually affect the strength and setting time of development. So having good quality materials is very key to having a good calcium aluminate type cement. So what's inside of a leveling compound? This is being used in every self-leveling compound in existence, from the products made by us to either ones from our competition. It is actually the ratio of these type materials that differentiates us from others. So what are these different compounds? What is the cake mix that we're talking about? First one is binders. We just talked about the history of those binders, but the two basic binder systems, cement-based, Portland-based, or calcium aluminate, and then gypsum-based. The Portland-based and the calcium aluminate, or cement, is a hydraulic binder which hardens in the air and underwater. A gypsum-based binder only hardens in the air. It is not water resistant. So most gypsum compounds are comprised of natural gypsum and then new technology that we'll talk about here in a minute with synthetic being alpha and beta particles. Second thing in our cake mix is actually a concrete filler. This is anything that when hydrated does not dissolve. Primarily it's calcium carbonate, which is chalk stone, or crystal silica, which is sand and gravel. Why do we need fillers in processes? We may need to extend the self-leveling. We may need to have something to help it stand on itself. We can reduce the price by the amount of filler that we add into the material. Or we may be seeing some technical requirements. Maybe it's a certain look that we have to have a wear-rated aggregate in that for that filler system. The third process in our cake mix is the dispersion powder. This is spray dried in polymers. This is your latexes. These dispersion polymers will actually dissolve in water. It increases the strength and formability of the material. We want to increase the adhesion. We want to increase the abrasion. And also can keep it from drying out too quickly. So in a process like calcium aluminate cement, we can use that in order to keep it from drying out too fast. Fourth product that we use within our self-leveling compound is a smoothing agent. You can kind of look at this as a smoothing compounds, either casein, which is a milk-based protein, or it's polyglycol. Primarily, guys are using polyglycol instead of the casein being milk-based proteins. This is the healing property of your self-leveling. So an easier workability for the installer to use if you use a product that contains smoothing agents within the material. Also used in toothpaste, gives you that nice smooth creaminess of that material. So you can imagine if you did not have smoothing agents within those products, how bad it would be to brush your teeth in the mornings. So more of the smoothing agent, better workability you have for the product. And then additives. These can be anywhere from setting and hardening accelerators. Maybe we need to speed up the process, or we may need to have a retarder. Again, like in a calcium aluminate-based cement binder system, we may need to slow the setting time just a little bit. Polymers are, again, additional additives, latexes that are added into the material. And then defoamers. A defoamer is very important in a self-leveling because we're basically taking the entrapped air in the system, drawing it to the top, keeping the actual self-leveling when it's finished and complete from kind of looking like Swiss cheese within the matrix. So we want to get all the air bubbles out of that material to give a more dense and more comprised material. So how do we manufacture these binder systems? How do we do this? So if you look at natural gypsum, we are taking a product, we mine it, put it into a transportation truck, goes into a manufacturing process. It is milled with a ball mill. Then your actual components are added to that, makes existing gypsum. Not a lot of technology needed to manufacture a natural gypsum self-leveler. Portland cement, two different processes, either wet or dry. Most manufacturers now are using it in the wet method. They're trying to control dust and particulates going into the air. The limestone is put into a ball mill and crushed. The additional additives are put into that material, and then it's added into a rotary kiln. Wet processes goes in one end, dry process comes out of the other. The material actually moves within the flume itself. You will get what they call a clinker at the end of the process, which is marble shaped. That is actually crushed once more time, and that is production of Portland cement. The difference between Portland and calcium aluminate is done basically the same way, with the exception it's put into a blast furnace instead of a rotary kiln. So we actually get a cool line vertical furnace that actually melts or makes a molten structure out of the calcium aluminate cement properties. That's why it's called cement fondue in France. So it's actually a melted process. That is cooled, crushed into the ball mill again, and put into manufacturing process. So once we get to the actual raw material, the binders, the silica, and the fillers are actually loaded into a main silo, used at the top of the facility, and then everything else is processed through by gravity feed. The premixer goes through, then the mixed components, the smoothing agents, and the dispersion powders are actually added usually by hand in order to make sure the dosing is correct, and then they go into a conveyor system and on into your process that we're doing today. So what is some of the chemistry we need to look at when we're choosing a self-leveler? Is there questions that we need to ask? First thing we need to consider, are we going over porous or non-porous substrates? Are we going over existing gypsum substrate? Are we going over epoxy, maybe a terrazzo floor, or just standard concrete? Would there be a chemical reaction between the substrate and the self-leveling compound? Is there need to be a barrier between the two processes? What is the condition of the substrate? Are we talking about minor self-leveling? Are we talking about major renovations? Are we trying to repair cracked and deteriorated substrates? Look at the needs for your renovation project. Is it time sensitive? Are we doing an MRI room in a hospital? Is there strength requirements? Is there forklift traffic being used in this situation? Do we need water resistance? Are we talking about something interior, exterior? Is it a critical substrate, a vinyl asbestos tile or existing sheet vinyl? Are there strength requirements or load capabilities? These are some of the checklists that we need to go through in order to determine the right self-leveler to be used. So again, natural gypsum, good for critical backgrounds, great for thicker applications in that one application compared to cement-based self-leveler. No shrinkage in natural gypsum. Leveling over existing gypsums due to the same raw material, so there's no chemical reaction between a gypsum system binding to an existing gypsum system versus that going over a cementitious product like Portland or calcium aluminate. Portland cement, best suited for going over existing concrete. Again, we're using the same raw material of the base, so we don't have to worry about chemical reaction between cement and cement, Portland and Portland. If we're looking for something with more water resistance or more freeze-thaw capabilities, again, this is where we look at Portland cement. And then calcium aluminate. This is for higher PSI strength. Maybe we need to get a higher hydration at colder temperatures. So if we're looking at warehouse applications or something that we need very high PSI strength very quickly, again, MRI rooms in hospitals is a perfect example, is where we use something based with calcium aluminate cement. So unfortunately in our industry, we have not really evolved in the production of cement binder systems since the 1930s and the 1918s when we're doing calcium aluminate and Portland. So we've been using this brick phone for years without actually increasing the technology that we need. Luckily, within the last 20 years, we've had an involvement in self-leveling. We had an emergence of new products and new technology to help us in this industry. Now we have products that are synthetic. With over the last 20 years, the synthetic gypsum system is being used in drywall and actually in self-leveling compounds. It actually eliminates the need to mine. It contributes to a safer, cleaner environment. And then we get high-performance self-leveling that is environmentally friendly drywall as well. So what is synthetic gypsum? How is it produced? When you have a coal burning or natural fossil fuel burning plant, you have sulfur dioxide, which is our greenhouse gases, coming out from that power plant emissions. We need to make sure that we capture those to make our environment more clean. So we spray either limestone or calcium carbonate within the flume, and the calcium combines in with that sulfur dioxide and makes calcium sulfate. You can take calcium sulfate, we hydrate it, and then we put it into a furnace in order to clean and purify it, and we can actually come out with synthetic gypsum. One distinguishing factor we need to make sure of that it is not fly ash. Fly ash is coming up through the top of the flume. It's more carbon-based. Synthetic gypsum is that byproduct of the sulfur dioxide and the calcium being sprayed into that flume. But when we're actually producing synthetic gypsum, we can come up with two different qualities of product. We have alpha product and we have beta. This is manufactured in technology, so it takes special equipment to produce both products or a combination of both products. Synthetic beta gypsum is dewatering of the dehydrate by rapid heating. So basically the rotary furnace or the cooker autoclave does not hold the pressure as long as we need it to. That rapid exhaustion of water becomes a more of an amorphous shaped structure. Kind of imagine Q-tips. If you're stacking Q-tip on top of Q-tip, it's very spongy and you have spacing in between that product. So you're not going to get a very high PSI strength out of a synthetic beta gypsum system. So synthetic beta is very unstable. It's still very porous. We don't have a very consistent quality of it. Our PSI strength is about 1885, which is not very good for a self-leveling system. It's very unorganized. It doesn't have much shape. Right now, we're looking about 30% of it being used in synthetic-based drywall material. And it's estimated within the next year, we'll be producing about 20 million tons of synthetic gypsum every year. So a large supply of matrix network for this material. So we've had really a missing link between existing gypsum, natural gypsum, and beta. We combated the synthetic with having no mold and mildew growth, but we really lacked the PSI strength that we needed to produce a quality self-leveling product and have the consistency of that product. So we have alpha gypsum used in our synthetic gypsum compounds. So alpha gypsum compared to beta, 6,526 PSI, compared to beta, which is 1885. So we can get a very high PSI strength with a controlled environment that can go over that critical substrate. So now we have something that dries very quickly. We can have dust reduce capabilities. We're helping out the environment because we're taking a waste product from a coal burning plant. Very hard, very strong, very dense. It is very stable because we can control it within the laboratory, and requires half the water needed that you would have to have in a beta type system for a self-leveling. So better lightweight capabilities for that material. So look at some of the benefits of synthetic alpha gypsum. We can go over existing substrates. So coverage of that black asbestos cutback when we use a primer system and a synthetic gypsum system. So we can eliminate some of the asbestos abatement in it. We don't have to worry about continuing to add into the landfill in order to get a smooth, sound, stable substrate. So our benefits of synthetic gypsum, we're taking that waste product, we're taking the natural gassing coming out of the coal burning plant and making it better for our environment. So synthetic gypsum requires no hazard warning on the back. It is not caustic like you would with a Portland type cement. We are very eager to use this product in processes like healthcare and education. So now we need to look that there is a better way to renovate. The days of having the guy on his hands and knees learning to do a trial work is getting to be farther and farther from the truth. Proper training gets to that person that can do that, but it's getting harder to find quality craftsmanship to do that. So instead of getting on your knees, doing trial work, we can actually prime and pour, like you see on the right, to give you a better substrate. No longer do we have to worry about demolition and renovation in order to get to that clean substrate. Usually we would have to demo the existing VCT that you see on your right in order to trial a patching compound before you could install your new LVT. So there is that better way to renovate. When synthetic gypsum systems have been used, we can take even the existing roof structure, proper priming being done, and then a synthetic gypsum before installation of LVT. So how does this affect each one of you? What are some of the effects of synthetic gypsum being demanded upon you in your workplace? Your end customer is demanding a better subfloor. No longer do we have the substrate that is just okay or acceptable. We are doing higher end products. Products like LVT and soft goods demand better substrates. And as you can see on this screen, these are before and after pictures of critical substrates and deteriorated substrates that's been fixed and processed with a self-leveling compound. So what can we do? We need to inspect the job site before renovation starts. We need to put eyes on that system. Call your local representative, have them come out with you in order to look at these processes, come up with the best recommendation. Ask the right questions. And I would say that just ask the questions. The more questions we can get answered up front, the better we have for a demand for a better subfloor. Demand some transparency. Make sure that everywhere from the owner to the architect to the general contractor to the subcontractor are all on the same page, and demand some transparency from each one of them. Make sure that we're all on the same page to say and work holistically to make sure the process and the project is successful. Let's make the best choice for consideration. What is the existing substrate? What are we dealing with to start? and what are we looking at as the finished process. The demands for a hard tile will be different than the demands for a soft goods process. And then we need to specify the desired products to be used to take the necessary steps to have that smooth and sound installation. Because right now we're dealing with a industry where the craftsmen are getting further and further behind and harder to find. We have the two universities of the big box stores that are training end users how to install floor covering. But it takes people like FCICA in order to train and properly train these folks in order to be good quality installers and project managers. So with that, I want to thank you for taking time for our presentation, and I will turn it back over to you.
Wonderful. What an excellent presentation. Thanks so much, Shane. So at this time, if anyone has any questions, and Shane, is it okay now if they ask product-specific questions?
Product-specific questions are okay at this point, yes.
Okay. So if anyone has any questions, on the left side of your screen, you will see an additional box on the bottom part, and you see Q&A. You can go ahead and type your questions in there and submit them. And Shane can take care of that for you. And again, this can be anything about his presentation, or this could be Schönox product-specific questions. So take advantage of this time to talk with a technical representative. Shane, do you have anything else that you'd like to talk about, maybe Schönox specific?
Schönox specific, I want to invite everyone to come and see us at the convention next week. We will be there. I will be there in person. So please come by the booth. Please stop and say hi to us. We do have a new process, a new technology that has been released this year. We do now have a hybrid system, which combines the benefits of synthetic gypsum, of non-shrinkage, with the faster dry time of a cement product. So if you'd like some more information on our synthetic hybrids, please again see me at the booth at the FCICA next week.
We have a whole half hour remaining. So if you have a question that you are dying to ask, and it could be a long answer, that is cool, because we have the time. So I highly recommend that you think of something and submit it. And I see some Sims on this webinar, and I would recommend that those Sims reach out with a question. Okay, we have a question. Look at that. Is it important to have the area climatized prior to applying your products?
Yes, in most applications, we have a couple self-levelers that are used for exterior use, but for any interior renovation, we do need to have it climatized. We would prefer that we have acclimated conditions as per it being occupied. We would like that to be 48 hours before and then 48 hours after. We do have some minimum temperatures like 45 degrees. It needs to be maintained with most self-leveling compounds. If we do not, then we have to worry about the actual product freezing within the application process. So yes, acclimation is preferred.
Okay, here's another one. What is the thickest pour for your self-leveling products?
It can be done in lifts, but a product like Schönox US can be installed at 3 inches within one lift, and then we can do multiple lifts if we need. The big thing to remember when you're doing multiple lifts is to make sure that the lift on the bottom is at your thickest application, and then you get thinner as you go up. The thicker the material, especially on a cementitious product, the more drying or tensile pull that you have with the shrinkage. So we want to make sure that you have less shrinkage as you go up into the installation. Make sure you use a primer coat between each lift in order to make sure you got good bond between the two lifts. We also manufacture products like Schönox SSE Plus, which is a dry pack material that can be installed at 10 inches, and then we can go upwards from there if we need to.
Okay. Are primers still required over the underlayment?
If we're talking about over the overlayment, it's according to what the application is on top of it. If we're looking at using a synthetic gypsum system, then I would use a primer on top of it before I would put a cementitious like thin set on top. But normally, if you're looking at a standard self-leveler, then there's probably no need to prime if you're applying a modified thin set or an adhesive application on top of it. What we get into a lot in our situation, especially with natural gypsum, is the excessive dust that's made with that product. So primers are normally done over an existing natural gypsum in order to combat that dust. That may be the answer to that question. Always prime underneath a synthetic or a natural product, being cementitious or gypsum. Primer is always required first.
Does Schönox provide the primer products?
We do. We have 3 basic primer systems. We have 2 that are engineered for our porous material, being Schönox VD and then Schönox KH Fix, which is designed primarily for gypsum applications. And we also have a non-porous primer called Schönox SHP that can be used over existing epoxies, ceramic tiles, terrazzos, and that type application.
Okay, so I'm looking over the handouts that were provided. And my question is, what's the difference between AP Rapid and AP Rapid Plus?
AP Rapid is a hybrid material that can be installed up to 1/2 inch. AP Rapid Plus is also a hybrid that goes into thicker applications. AP Rapid Plus is used in conjunction with our Schönox 3D Renotex and our rock wool material, mineral wool material that can be used in our multifamily applications. So major difference between the two, AP Rapid Plus is made for a thicker application.
Okay. Now, one of your handouts is regarding multifamily projects. What's that about?
We manufacture a lot of material, especially our synthetic gypsum systems. We produce Schönox AP, which is a alpha particle synthetic gypsum. Has a compressive strength of 5,800 psi. We can take existing gypsum, like in multifamily, apply a primer coat with KH Fix, self-level with AP, and then the next morning we're ready for new installation, which gives you a strong, sound, and stable. We also produce Schönox APF, which has a fiber reinforcing. So if you have a slab with deflection, we can actually use this product in order to combat some of the deflection in that substrate before you install. And then just mentioned AP Rapid, we can have installation done within 6 hours, or AP Rapid Plus, if we have a deeper installation, we can install, let it dry overnight, even at 1.5 inches, and we're ready for floor covering the next day.
Awesome. Okay, here's another question. if I would direct glue to the product, how would you check the moisture content of self-leveling product?
Self-leveling products need to be tested before, and it's depending on the system. If you're looking at a Portland-based cement or a calcium aluminate-based cement, that can be done with either a matte bond test or a calcium chloride testing done by ANSI standards. On gypsum substrates, there is probe meters that can determine moisture percentage, but a bond test is always the best option in order to test for moisture within the system.
Now, if someone is working with your products on a project and they run into, I don't know, some weird conditions that are difficult to plan for ahead of time, can they request for a Schönox rep to come visit the site, or is there a way they can call and ask questions?
Yes, twofold. I would suggest that everyone install the Schönox app on their device. If you install the Schönox app, there is a tab within our application that says Find a Representative. All you have to do is type in your zip code, and it will find the local Schönox representative to you. That is their cell number and their email address listed on the app. You can call them direct. We are more than willing and actually would encourage people to invite us out to their job sites to do that. We're at Schönox Technical Services. We are here 24 hours a day, 7 days a week to answer your questions. They can call the toll-free number at 855-391-2649 to contact us here at Technical Services, or they can send me an email at my email address, sjenkins@hpsubfloors.com.
Cool. I did not know that Schönox had an app. That's awesome.
Very good app. Our app also has YouTube videos, has product calculations, has all the data sheets, so it's a very good, useful resource tool.
Wow, yeah. That sounds like a very good help on a project. So, Shane, do you have any subfloor challenges that you're currently dealing with?
Subfloor challenges come about a daily basis, sometimes an hourly basis. We have a world's worst subfloor contest that we present every year. We had over 100 entries last year, people facing those challenges, and on a day in, day out basis, we get phone calls quite often from guys and gals out in the field trying to face those subfloor challenges. And that's where Schönox really comes in with the technology of products in order to repair those subfloor needs. Again, we're demanding a better subfloor now, so we cannot just expect the mundane. We must actually look for perfection, and that's what we do when we talk about Schönox. We want to be on it. We want to be on your project, helping you out with those subfloor challenges in order to give you the right situation and the right solution for your problems.
Okay. I am not seeing any more questions coming through.
Okay.
So I think, we've had almost 15 minutes here. So why don't we go ahead and wrap it up? Shane, thank you so much today for presenting this webinar sponsored by Schönox. And certified installation managers who attended this webinar on the education platform can now click on the credit tab and complete the submission process. And if you are looking for other continuing education opportunities, you can access previous webinars by navigating to the courses section and clicking the on demand button, and visit our training resources page on the FCICA website for other offerings. And clearly, Schönox has some pretty cool resources out there, so I'm sure you can check out their YouTube channel for other videos, and it's quite likely that you could submit those videos for credit SIMs if you are looking for more opportunities. So again, don't be afraid to get creative. And if anyone else has questions for Shane, you can reach out to him. He did provide his email. And let's see. I want to see if it is on the presenter tab. Unfortunately, it is not, but you can always email me as well, and I can pass those questions along to Shane if you do not have his contact. Thank you so much, everyone, and have a fantastic rest of your day.